Hello everyone, I am Guruprasad Upadhya. So in this lecture, I am going to discuss inverse Laplace transform by convolution method or using convolution theorem and how to solve the differential equations using Laplace transform method. Using convolution theorem, find the inverse Laplace transform of the following. In that, the first question is, find L inverse of s square by s square plus a square whole square. Now, what is convolution theorem? Laplace transform of convolution of f of t and g of t. Convolution of the two functions f of t and g of t is nothing but the product of their Laplace transform. Therefore, inverse Laplace transform of the f of s into g of s is convolution of f of t and g of t. Here f of s is s by s square plus a square, g of s is also s by s square plus a square. See this. So we are going to write this s square by s square plus a square whole square is product of the two functions. One is f of s, capital F of s, one is capital G of s. Now find the inverse Laplace transform of this capital F of s and capital G of s. So both are s by s square plus a square, that is cos a t. F of t is also cos a t, g of t is also cos a t. By the convolution theorem, inverse Laplace transform of this f of s into g of s is nothing but f of t star g of t. That means convolution of f of t and g of t. Convolution of two function is integral 0 to t f of u g of t minus u du. Here you are integrating with respect to u, then limit is from 0 to t, that is convolution of the two functions f and g, small letter f g. Now f of u, f of t is cos a t, f of u is cos a u, t is replaced by u, and g of t minus u, g of t is also cos a t, therefore g of t minus u is cos a into t minus u, that means cos a into t minus u means a t minus a u. So substitute that, and hence it is integral 0 to t cos a u into cos a t minus a u du. Now how to integrate this? Product of the two trigonometric functions, use cos a cos b formula, and we know that cos a cos b is half cos a minus b plus cos a plus b, or you can write cos a plus b plus cos a minus b, both are same. Now here a is nothing but au, and this capital B is nothing but cos b, cos a t minus a u means b is a t minus a u. Now a plus b becomes, here a u cancels, a plus b is a t, a minus b is a u minus minus a u is 2 a u minus a t, a minus b is 2 a u minus a t. Substitute these two, a plus b value, a minus b value here, therefore this integral is nothing but half into integral 0 to t cos a minus b, that is 2 a u minus a t, plus cos a plus b, that is cos a t. Now when you are integrating with respect to u, cos a u integration is sin a u by a. Here you are integrating with respect to u means the coefficient of u here is 2a, therefore divided by 2a, but cos a t is constant. When you are integrate with respect to u, cos a t is constant. Integration of constant with respect to u is u into that constant, and hence half into sin theta, theta means 2au minus a t, divided by coefficient of u is 2a, plus constant into u cos a t, and limit for u, upper limit is t, lower limit is 0. When you apply upper limit t, 2at minus at, 2at minus at is at sin at. Lower limit u is 0 means Sine of minus 80, that is minus sin 80. Upper limit value minus lower limit value, sin 80 minus minus sin 80, that is plus sin 80. 2 sin 80 by 2a, cancel 2, sin 80 by a, plus t cos 80, lower limit 0. And hence it is half into sin 80 by 2a plus sin 80 by 2a means 2 sin 80 by 2a plus t cos 80. By taking a common outside, this becomes, add these two, it becomes 2 times, cancel 2, sin 80 by a is taken outside, sin 80 plus, when you take common term a outside, this becomes 80 cos 80. The answer is 1 by 2a sin 80 plus 80 cos 80. One more example, s square by s square plus a square into s square plus b square. So first step is write it as product of two functions, that is s by s square plus a square, and here s square is there, so one more s is here, s by s square plus b square. This is your capital F of s and this is capital G of s, and their inverse is small f of t is L inverse of f of s, that is cos 80, g of t is L inverse of g of s, that is cos bt. And hence by convolution theorem, L inverse of f of s into g of s is convolution of this f of t into f of t and g of t. So convolution of f and g is nothing but integral 0 to t f of u g of t minus u du, f of u cos a u g of t minus u cos b into t minus u, so bt minus bu, cos a cos b, same as the previous problem. A is AU, capital B is BT minus BU, A plus B becomes AU minus BU means A minus BU plus BT, A plus B. A minus B is AU minus minus plus BU, AU plus BU becomes A plus BU minus BT. Substitute this A plus B and A minus B value here, and hence it is half into integral 0 to t cos a minus b, that is a plus b u minus bt, plus cos a plus b, that is a minus b u plus bt. Now cos theta plus cos, integral of cos is sin theta by coefficient of u is a plus b. So half of sin angle is a plus b into u minus bt divided by a plus b. Here also integral of cos is sin a minus bu plus bt by a minus b, and carefully apply the limit for u. Upper limit is t, lower limit is 0. Here upper limit is t means a t plus bt minus bt, at plus bt minus bt, bt minus bt cancels, at remains, sin 80 by a plus b. Lower limit 0 means this part becomes 0, minus bt, sin of minus bt is minus sin bt, so lower limit, so it becomes plus sin bt by a plus b. And similarly here upper limit t means a t minus bt plus bt cancels, sin 80 by a minus b, and lower limit 0 means sin of bt, so lower limit value, so minus sin bt by a minus b. Now how to simplify this? Sin 80 by a plus b plus sin 80 by a minus b. Take sin 80 common outside, 1 by a plus b plus 1 by a minus b, and from these two take minus sin bt, take outside, minus sin bt is taken outside, 1 by a minus b minus 1 by a plus b, because I taken minus sign outside, so this becomes minus, minus minus plus. Now how to simplify this? By taking common denominator, a plus b into a minus b is a square minus b square in the denominator, a minus b plus a plus b, a minus b plus a plus b means 2a cancel 2, a sin 80 by a square minus b square. Similarly this half is for this also, a plus b minus a minus b, minus a plus b, that means 2b. So 2 is cancelled. So b sin bt by a square minus b square. So final answer 1 by a square minus b square into a sin at minus b sin bt. Follow no? So you simplify this separately and this separately, and that 2a, it becomes 2a and this becomes 2b. Take 2 common outside, cancel it. A sin at minus b sin bt divided by this common denominator a square minus b square. So 1 by a square minus b square into a sin at minus b sin bt. So this is how we can use convolution theorem to find the L inverse of this function. One more example, 1 by s into s square plus a square. Here take 1 by s square plus a square as first function, 1 by s is second function. This is your f of s and this inverse is 1 by a sin at, and 1 by s is g of s and its inverse g of t is inverse of 1 by s is 1, and hence L inverse of 1 by s square plus a square into 1 by s is nothing but convolution of f and g, that is 0 to t f of u. F of u is 1 by a sin a u. G of t minus u, t is replaced by t minus u. G of t is constant function, that is 1. This t may be anything. G of t is 1. Therefore, g of t minus u is also 1. By substituting, so you will get 1 by a integral 0 to t sin a u into 1 into du. Integral of sin a u is nothing but minus cos a u by a. Minus cos a u by a. Limit is from 0 to t. For the upper limit, it is minus cos a t. For the lower limit, it is minus cos 0 means minus 1. Upper limit minus lower limit. Therefore, minus cos a t plus 1 or 1 minus cos a t by a. Here outside one more a. So it is 1 minus cos a t by a square. So this is L inverse of 1 by s into s square plus a square. Followed? Okay. Next, how we can solve the differential equation using Laplace transform technique. Here is one simple problem. Y double dash plus 2y dash minus 3y equal to sin t, and y of 0 and y dash of 0 both are 0, it is given. So this is initial values, y at 0, y dash at 0, that is 0. Suppose Laplace transform of small y is capital Y. Assume Laplace transform of y is capital Y. Then to find Laplace transform of y dash, multiply this by s and then subtract y at 0. So s into capital Y minus y at 0. But y at 0 is 0. Here it is given. Therefore it is s into y. Laplace transform of y double dash. So multiply the previous Laplace transform by s, then minus y dash at 0. Therefore it is s square capital Y minus s y at 0 minus y dash at 0. But y at 0 and y dash at 0 both are 0. Therefore Laplace transform of y double dash is also becomes s square y. And we know that Laplace transform of sin a t is a by s square plus a square. Therefore sin t Laplace transform is 1 by s square plus 1. The given equation is y double dash plus 2y dash minus 3y equal to sin t. Taking Laplace transform on both sides, so this becomes s square capital Y plus 2s capital Y minus 3 Laplace transform of small y is capital Y equal to 1 by s square plus 1. So if you take y common outside, it becomes s square plus 2s minus 3. S square plus 2s minus 3, if it is 0, you will get s equal to 1 and s equal to minus 3. Therefore factor is s minus 1 into s plus 3. S minus 1 into s plus 3 is nothing but s square plus 2s minus 3. See how to factorize? Assume that s square plus 2s minus 3 is 0. Then use calculator to find the roots. So you will get roots is 1 and minus 3. S equal to 1 means the factor is s minus 1. S equal to minus 3 means factor is s plus 3. So dividing by s minus 1, s plus 3, capital Y becomes 1 by s square plus 1 into s minus 1 into s plus 3. Now, before finding the Laplace transform L inverse of or inverse Laplace transform of this capital Y is First you do the partial fraction. S square plus 1 is irreducible quadratic factor, therefore assume that it is as plus b by s square plus 1 plus c by s minus 1 plus d by s plus 3. To find c value, close this part, put s equal to 1. 1 square plus 1, that is 2, 1 plus 3, 4. So totally 8. 1 by 8 by s minus 1. Put s equal to minus 3. So 9 plus 1 is 10 into minus 3 minus 1 is minus 4. So minus 40, minus 1 by 40 by s plus 3. So this becomes as plus b by s square plus 1 plus c by s minus 1 plus d by s plus 3. So I already discussed how to find this linear factor. This c is nothing but, in the previous expression, the denominator of c is s minus 1, close it, put s equal to 1. So 1 plus 1 is 2, 1 plus 3 is 4, so totally 8, 1 by 8. So that is c. And this is d. How to find d? So close this s plus 3, 1 by s square plus 1 into s minus 1 with s equal to minus 3. So minus 3 square is 9, 9 plus 1 is 10 into minus 4. So minus 40, 1 by minus 40, minus 1 by 40. This is d value. But to find as plus b, so multiply throughout by s square plus 1 into s minus 1 into s plus 3. Left hand side is 1. Right hand side is as plus b into s minus 1 into s plus 3 plus 1 by 8 into s square plus 1 into s plus 3 minus 1 by 40 into s square plus 1 into s minus 1. Okay. Now compare the coefficient of s cube. S into as. So as cube. Coefficient of s cube is a. Here s square into s is s cube. Coefficient of s cube is 1 by 8. S square into s is s cube. Coefficient of s cube is minus 1 by 40. A plus 1 by 8 minus 1 by 40. This is coefficient of s cube in the right hand side. In the left hand side, no s cube. Therefore, its coefficient is 0. To find a value, take these two right side. 1 by 40 minus 1 by 8. Just substitute in calculator. You will get minus 1 by 10. So that is a value. Now to find b value, put s equal to 0. Left hand side is 1. When s is 0, it is b into minus 1 into 3, minus 3b. 1 equal to minus 3b. When s is 0, this is 1 into 3 into 1 by 8. So 3 by 8. When s is 0, minus 1 into minus 1 by 40 is plus 1 by 40. So 3b is, take minus 3b, left side. 3b becomes 1 by 8 plus 1 by 40 minus 1. Just substitute in calculator. 3b is 3 by 8 plus 1 by 40 minus 1. That is 3b. b is divided by 3. Answer is divided by 3. So you will get minus 1 by 5. After calculating a, b value, then find the inverse Laplace transform of this, that is required y, the solution of this differential equation. Therefore, y is a into s by s square plus 1. Inverse of s by s square plus 1 is cos 1t. A is minus 1 by 10 cos 1t. Plus b into 1 by s square plus 1. Inverse Laplace transform of 1 by s square plus 1 is sin t. And b is minus 1 by 5 minus 1 by 5 sin t. Plus c into 1 by 8 into 1 by s minus 1 inverse is e power minus t, plus minus 1 by 40 into 1 by s plus 3 e power minus 3t, minus 1 by 40 into e power minus 3t. So this is how we are able to do the partial fraction by simple technique. And then how we can solve this differential equations using Laplace transform. One more example. Y double dash minus 3y dash plus 2y equal to 4t plus e power 3t. Y at 0 is 1, y dash at 0 is minus 1. If Laplace transform of small y is capital Y, assume, then Laplace transform of y dash is s into capital Y minus y at 0. S into capital Y minus y at 0. y at 0 is 1. Therefore, it is sy minus 1. Laplace transform of y double dash is, multiply this by s first, s square capital Y minus sy at 0 minus y dash at 0. So, this is Laplace transform of y double dash. Now, substitute the y at 0 and y dash at 0, 1 and minus 1, it becomes s square capital Y minus s minus minus 1, so plus 1. And we know that Laplace transform of t is 1 by s square, Laplace transform of e power a t is 1 by s minus a. Now, substitute that. So, this is given equation, differential equation, taking Laplace transform both sides, we will get y double dash Laplace transform, we already simplified here, s square y minus s plus 1 minus 3 into y dash Laplace transform, that is sy minus 1 plus 2 into Laplace transform of small y is capital Y equal to Laplace transform of 4 into Laplace transform of t is 1 by s square. So, 4 by s square plus 1 by s minus 3. Now, s square capital Y minus 3s capital Y plus 2 capital Y. S square minus 3s plus 2 into capital Y equal to, this minus s is taken right side, it becomes plus s. 1 minus 3 into minus 1 is plus 3, 1 plus 3 is 4, take right side, it is minus 4. Now, how to take this common denominator here? S square into s minus 3. So, numerator is 4 into s minus 3 plus 1 into s square plus s minus 4 into s square into s minus 3, that is numerator. Then divide by this. This is nothing but s square minus 3s plus 2 is s minus 1 into s minus 2. Finally, divide by s minus 1 into s minus 2. Therefore, capital Y is, see this, 4 into s minus 3 plus 1 into s square plus s minus 4 into s square into s minus 3. These two, that is numerator, divided by s square into s minus 3 into this. So, this is s minus 1 into s minus 2. Now, use the partial fraction technique. So, very simple logic, a by s square plus b by s plus c by s minus 1 plus d by s minus 2 plus e by s minus 3. To find a value, close this here s square, put s equal to 0 throughout. When s equal to 0, these two become 0, this is minus 12. Denominator, when s is 0, it is minus 6. Minus 1 into minus 2 into minus 3 is minus 6. Minus 12 by minus 6 is 2. Therefore, a is 2. To find c value, close this part s minus 1, put s equal to 1. 4 into 1 minus 3, 1 minus 3, 4 into 1 minus 3, so it becomes minus 2, minus 8. When s equal to 1, s square is 1, so it becomes minus 7 togetherly, and s square is 1, this is minus 2 and this is minus 3. Minus 2 into minus 3 is plus 6. See this, 6 plus 1, 7 minus 8, that is numerator, minus 1. Denominator, when s equal to 1, 1 square is 1, close this part, 1 minus 2 is minus 1, 1 minus 3 is minus 2. So, denominator becomes 2, 1 into 2 is 2, numerator is minus 1. So, minus 1 by 2 by s minus 1. Similarly, to find this d value, close this s minus 2, put s equal to 2. When s equal to 2, this is minus 4 plus 4, minus 4 plus 4 cancels, here 4, when s equal to 2, it is 1 and it is minus, when x equal to 2, it is minus 1 into minus 2, that is 2, 4 into 2, 8. And denominator, when s equal to 2, it is 4 and this is 4 and close this part s minus 2, put s equal to 2, 2 minus 1 is 1, this is minus 1, so minus 4, 8 by minus 4 is minus 2. And similarly, d value, put s equal to 3 and close this in the left hand side, denominator s minus 3 is closed and put s equal to 3. So, this part is 0, 9 and this part is 0, 9, 3 square is 9, again denominator 3 square is 9, cancel 9 and here 3 minus 1 is 2 and 3 minus 2 is 1. So it is 2. 1 by 2. That means 9 by 9 into 2. So 1 by 2. That is D value. Now to find this A value, take this left side, S square into S into S into S, totally S power 5. When it comes here S power 5, this becomes S power 5 by S square term. That is S power 5 by S square is S cube. S power 5 by S is S power 4. Here also S power 4, S power 4, S power 4. S power 4 coefficient. Here left hand side S square into S, S power 4. Coefficient of S power 4 is 1. 1 equal to 2. Sorry, not this. This is coefficient of S power 3. So 1 equal to 3. Sorry, actually you are going to find this B value. So B minus 1 by 2 minus 2 plus 1 by 2. So minus 1 by 2 plus 1 by 2 cancels, minus 2. B minus 2 equal to 1. Therefore B is 3. This is how we are able to find A, B, C, D, E value. Follow now? Comparing by multiplying throughout by S square into S minus 1 into S minus 2 into S minus 3, the coefficient of S power 4 is B plus C plus D plus E. Here coefficient of S power 4 is 1. So B plus C plus D plus E is 1 and B is 1 minus C minus D minus C. So it becomes 1 plus 2, that is 3. That is how we can find this partial fraction. Then find the inverse. The final answer is 2 into 1 by S square inverse is T. 3 into 1 by S Laplace inverse is 1. So 3 into 1 is 3. Minus half into 1 by S minus 1 e power t. Minus 2 into 1 by S minus 2, that is e power 2t. Plus half into 1 by S minus 3 inverse Laplace transform is e power 3t. So this is the solution for this differential equations with this initial conditions. Now one more example here. Y triple dash minus 3y double dash plus 3y dash minus y equal to t square e power t. You know how to find Laplace transform of t square e power t? By the first rule, e power t, ignore t square Laplace transform, s is replaced by s minus 1. So it is 2 factorial by s cube, 2 factorial by s minus 1 whole cube. And y at 0 is 1, y dash is 0, y double dash is minus 2. Now Laplace transform of y is by taking Laplace transform both sides. Y triple dash Laplace transform is s cube into capital Y, s cube into capital Y minus s square into y at 0, that is 1. So minus 1 into s square minus s into y dash is 0 minus y double dash. So y double dash is minus 2, minus minus plus 2. This is Laplace transform of y triple dash. Minus 3 into Laplace transform of y double dash, s square capital Y, that we already discussed in the previous example, minus s square capital Y minus s into y at 0, that is 1, minus s into 1 minus y dash at 0, y dash at 0 is 0. So it is s square y minus s plus 3 into y dash Laplace transform, s into capital Y minus y at 0, that is 1, and then minus Laplace transform of this small y is capital Y equal to Laplace transform of t square is 1 by s square, 2 by s cube, t square into e power t is 2 by s minus 1 whole cube by the first rule of the Laplace transform, shifting rule. Okay. Now s cube y minus 3s square y plus 3sy minus y equal to 2 by s minus 1 whole cube plus s square. Here it becomes plus 3s, you take right side, it is minus 3s, 2 minus 3, that is minus 1, take right side, plus 1. Therefore s cube minus 3s square plus 3s minus 1 into capital Y is 2 by s minus 1 whole cube plus s square minus 3s plus 1 by taking common denominator 2 plus s square minus 3s plus 1 into s minus 1 whole cube divided by s minus 1 whole cube, but s cube minus 3s square plus 3s minus 1 is also s minus 1 whole cube. Dividing by this means denominator becomes s minus 1 whole power 6. Now how to find these factors? When you substitute in calculator, you get only one root, but it is cubic equation. So there are three roots. All the roots are same. 1, 1, 1. S equal to 1, S equal to 1, S equal to 1. It is nothing but factor is S minus 1, S minus 1, S minus 1. So s cube minus 3s square plus 3s minus 1 is s minus 1 whole cube. Therefore, capital Y is 2 plus s square minus 3s plus 1 into s minus 1 whole cube divided by s minus 1 power 6. Now, to make it as function of s minus 1, denominator is s minus 1 power 6, fine. Here s minus 1 cube, fine. Here s is there. S is nothing but s minus 1 plus 1. It is s only, s square minus 3s. S is nothing but s minus 1 plus 1 plus 1. Now this becomes function of s minus 1. To find the inverse by the first rule, e power t into L inverse of function of s. S minus 1 in the place of s minus 1, put it is s. Therefore, it becomes s plus 1 whole square minus 3 into s plus 1, minus 3 into s plus 1 plus 1. S minus 1 is s cube, denominator s power 6. Now simplify carefully. Here s square into s cube is s power 5. 2s minus 3s is minus s into s cube minus s power 4. 1 minus 3 plus 1. 2 minus 3 is minus 1 into s cube minus s cube plus 2 divided by s power 6. Now separate this. S power 5 by s power 6 is 1 by s minus 1 by s square minus 1 by s cube plus 2 by s power 6. Its inverse is 1 by s inverse is 1 minus 1 by s square means t minus 1 by s cube means t square by 2 factorial plus 2 by s power 6, 2 into t power 5 by 5 factorial. 1 by s power n inverse Laplace transform is, remember, t power n minus 1 by n minus 1 factorial. T power 5 by 5 factorial. 5 factorial is 120, cancel 2, so it becomes 60. The final answer is e power t into 1 minus t square by 2 plus t power 5 by 60. So this is the solution for this differential equations. So thank you for listening. Okay, if you have any doubts in these partial fractions, please call me or just mail your doubts. So I will send the answer. Thank you.